Okay. Triangle, special triangle is called the right triangle, but that very general triangle just consists of three sides. Okay, so you have a triangle. In general, it consists of three sides, three line segments. They're connected. Okay, so this is called triangle. About triangle, what do we have to know? We should know the areas. Okay, and usually we have given three sides, A and B and C. Okay, for the triangle, we needed to know a few things. So one called the triangle inequality. Triangle inequality. Okay, there's three inequalities there. If three A, B, C are the lengths of the three sides, then A plus B should be greater than C. B plus C should be greater than A. Okay, and A plus C should be greater than B. So you have those three inequalities. Then about the triangle, we have the so-called perimeter. Okay, perimeter is A plus B plus C. Right? We also have the so-called area. Now the question is area, how to find the area, formula for the area. The formula for the area is, if this is H, that area is going to be half of H times C. Now let me prove that why this is true. Okay, this is a triangle, right? And HC. Okay, H times C. I'm going to duplicate this triangle in this form and glue together. So what you get is get a parallelogram, and then I cut this move it here. So this portion of the triangle, okay, is going to move it here. Okay, so it is moved here, and what you get a rectangle. Okay, rectangle, the base is AC, the arch is height. Why it's a C? Because you move this piece to here. So that's why the total length is still C. And the width of the rectangle is height. So the area of this parallelogram is going to be the area of this rectangle. So H, and then divide by 2, you get the area of the triangle. Okay, divide by 2, you get the area of the triangle. Okay, so we have those formulas. So let's take a look at the following example. Okay, I have a 3, I have a, this is a 5, and that's a 7. I want to make sure this is indeed a triangle. Okay, well, 3 plus 5 is greater than 7, right? 5 plus 7 is greater than 3, and 7 plus 3 is greater than 5. Yes. Okay, they are satisfying three triangle inequalities. Okay. Can we find the area? We don't know. Okay. Okay, don't talk about candy, okay? Today's Halloween. Okay. So this is a triangle inequality. Now, what we can do is we can find the perimeter. Perimeter P is going to be 3 plus 7 plus 5, which is going to be 15. My question is, can we find the area? I haven't given you any formula yet. If you know the height, H, the area is going to be half of 7 times H. Okay, so 7H divided by 2. Okay, so, but we don't know the H. Okay, we don't know the H. Okay, we can find out later. Okay, we can find the area. Okay, No, we can get area, but we need that as a formula. Okay, but we can, yeah, the question is, what is that? Okay, can we find the h? We don't know yet, right? So this is a Chinese problem. Okay, but what we should know is, if I have a 7, okay, and those two triangles, let's see. If this triangle, this side is a 3, here's a 4, okay? Is this triangle A, B, C, D? So if I know the area of the triangle ABC is going to be 5, can I find the area of the triangle of the other one, ACD? Okay, so there's two triangles here. Okay. No, the area is, yeah, let's look at this one. So this triangle, these two triangles, you should know that they have the same area, same height. So each is the same height. So note that they have the same height, right? H. So for the area of the triangle ABC, I will get half of the base times height, which is going to be 5. Okay, and from here you can get to the H. H is going to be 10 over 3, right? Then you can find the area of the other one, triangle ACD, which is going to be the base is 4, the height is still H. Okay, so you got 2H. So now H is going to be 10, 3, right? 10 over 3, so it's 20 over 3. Right? All right, so now let's look at another special triangle. It's a right triangle, right? If this side is 5, this side is 12, this side is 13. Okay, and I tell you this is a right triangle, okay? And this is 13 square. Okay, so we don't need to mention Pythagorean theory, you know, at this moment. Okay, I just said this is a right triangle. What is the area? Right? So the area is going to be, triangle ABC is going to be half of base times height is going to be 6 times 5, 30. Right. If I draw the line, here's the 5, and this is going to be 5. This is going to be 7. Okay, from here to here, from here to here. Okay, I want to find out. This is like a triangle, right? So I want to find out the area of this triangle. Okay, this is A, B, C, D. Okay, find the area of the triangle, delta ACD. Can you do that? Well, the height is 5, so the area of the triangle ACD is going to be half of the base. The base is 7. The height is 5. So 35 divided by 2. That's it. Right? The height is 5. The base is 7. All right. So now I'm going to introduce two formulas. One is called the Pythagorean Theory. Right, one is called the Pythagorean Theory. Okay, so theorem says that if we have A, B, C, so this is going to be A, that's going to be, you know, I'm going to use a different letters. Okay. And this is A, that's a B, so A, B, C, that's a C. Okay. So the angle ACB is going to be 90 degrees if and only if it's like a triangle, if only if A squared plus B squared equals C squared. Okay, so that's called the Pythagorean theory. So now if you have a triangle, you have a 5, 12, 13, right? Find the area. First of all, you have to say this is a right triangle. Okay, you will see that 5 squared plus 12 squared is 25 plus 144. It's 169, 69, 13 squared. Okay, so then therefore, this triangle A, B, C, this by the Pythagorean theory, this triangle ACB is going to be, the angle is going to be 90 degrees. Okay, so you get a right triangle. So therefore, the area of this triangle ABC is going to be half of the base times height, which is 6 times 5, 30. All right, so this is use the Pythagorean theory. You figured out this is the right triangle. Okay, Pythagorean theory is not, you know, it's two direction. One is when you know A squared plus B squared equals C squared, then this is the right triangle. And the conversely, if it's the right triangle, then A squared plus B squared equals C squared. Okay. All right, so now if you have a right triangle here, if you know this side, if you know this side, okay, how about the other side? Well, by the formula, C squared equals 4 squared plus 5 squared, so 16 plus 25, which is going to be 41, so C is going to square 41. Okay. And conversely, if you have this side is 6, this side is 4, then you can, if it's right triangle, can you get the other side? Okay, we can call it H. It looks like a height. Right, so H squared plus 4 squared equals 6 squared. So H squared equals 6 squared plus 4 minus 4 squared is 36 minus 16. 20. So h is the square root of 20. Square root of 20 can be simplified with 4 times 5, so it's 5 square root of 2. All right, so this is the way how to do it. Now let me make it a little bit more complicated. If I have an isosceles triangle, this 10 and 6, can you find the area? Now to find this, it's an isosceles triangle. So if I draw a height, right? And you see that this one divide this triangle into 2 equal parts. So there'll be 2 equal triangles here. So this is 6, 6, and here's 5, and it's a 5. So this h. So you can find the h. Okay? H squared plus 5 squared equals 6 squared. Right? Okay. So h squared equals 36 minus 25. And that is going to be 11. So h is going to square 11. Therefore, the area is going to be half of the base times h. It's a square root 11. So it's 5 square 11. So it's not a rational number. The area is not a rational number. Right. Well, yeah, let's try another one. Let's go back to this here. It's 5, 12, and 13. Okay, and I draw the line here. I want to find the area of this triangle. Your 3 sides are given. How to find the area of the triangle. So the area is in half of 13 times h. It's impossible. I don't know the h. But 3 sides is given, so this triangle is already completely fixed. Right? So we are lucky here. We know that 5 squared plus 12 squared equals 13 squared. So this means it is right triangle. It is right triangle. Therefore, the area can be calculated just half of 5 times 12. Right? That is going to be 30. So 30 is the area of the triangle. Right? So using this factor, I can even get the height because half of 13, h is going to be 30. Okay, then h is going to be 13, h is going to be 60. So h is 60 over 13. All right. So if you know the area, you can get the height. Okay. So actually, you can get all the height to all the 3 sides, the altitude. Let's use the same idea. Let's look at the picture here. Because this is a 5 12, 13. Okay, we know this is right triangle, right? I pick up a point. It's perpendicular to here. It's perpendicular to here. It's perpendicular to there. Okay. So they have the same, well, that's too much. I don't want. Yeah, we can discuss this later. Okay. Yeah, no problem. Okay, let me ask you to the next problem. Okay, this is an isosceles triangle, and this side is 5, this 5, and 8. Please find the area. Okay, please do this. Anyone have answers? You got 12.5. Now this should be integer. Okay, what is the area of this triangle? Isosceles triangle. How do you get 20? You don't know. Okay, I already gave you some kind of hint. Here, you have to draw the height, right? You draw the height, and you get h. So 5, 5. So you get two identical right triangle. So this must be the middle point. So this side is 4, this side is 4. What is h? Right, h is going to be 5 squared minus 4 squared divided by 3, right? By the Pythagorean theory. So it's a 3. So h is 3. Right. If h is 3, yeah, you can get that 4 squared plus h squared equals 5 squared. So h squared is going to be 5 squared minus h, correct? So therefore, area is going to be half of the base times h. So it should be 12. 12 is correct answer, Rebecca. Okay? Now, if I make it an isosceles triangle, it's a 5, 5, 5, an equilateral triangle, can we find this area? Can you figure it out? All right, okay, let's do this. Okay, so same idea, you have to draw the height, right? So, but what they have here is this right triangle, this is the right triangle, right? So they're equal to, right? So this is a 5, here's a 5/2, right? Yeah, you don't use decimal, just fractions, right? By the Pythagorean theory, h squared plus 5/2 squared equals 5 squared, right? So you get h squared equals 5 squared minus 5/2 squared. So it's 5 squared minus 5 squared over 2 squared. Can we combine them? My answer is yes. And you take, yeah. So what you get here is a 4 minus 1/4. Yeah, h is a 3/4 and the 5 squared. Okay. So now if you take h radical, okay, so that would be square of 3, and square of 4 is 2, and you have 5. Square of 5 squared is 5. So this is h, okay? This is h. So once you find the h, then you find the area. Area of the triangle is going to be half of the base. Base is 5, and the height, okay? So I get 25/4 and square of 3. Right? All you have to do is find the height. And for isosceles triangles, the height, you can use the Pythagorean theory to find the height. Right? I'll let you to try it again. So there's a different problems. Here's 10, okay? 13, 13. Find the area of this triangle, please. Stop. Erase it, please. All right. Anyone give me an answer, please? Can we find the area of this triangle? Well, we just need to find the height, right? Can you find the h? Okay, so h is 12, right? So you just by the Pythagorean theory, h is 12. So this time you don't have a irrational number, right? So 5, 13, h. So 5 squared plus h squared equals 13 squared. So h squared equals 13 squared minus 5 squared. So 169 minus 25, 144. Okay, so h is going to be 12. Then you solve the problem, right? So the area is going to be half of the base times 12, and that is going to be 60. Okay. Yeah, that would be 60. All right. So let's do one more problem. Then I'm going to work on some others. Okay. So we have a trapezoid. Trapezoid means these two lines parallel, right? Okay. I draw the line here, and this is going to be 7. Okay. So if the area of the ABCD, okay, here. So if the area of the triangle ABC is going to be 7, what is the area of the triangle BCD? Okay, the other one. Okay. So for the trapezoid, if you know the area of the other triangle, can you get the area of the one triangle? You can get the area of the other triangle. Yes, right? Can you do that? All right, anyone gave me answer? Please hurry up. Okay. Now here's in the basic math class, geometry problems will be not direct problem. No, it's not like a plug into the formula and you get the answer. Like you find the area, if you know the base, you know the height, blah blah, and you plug the number into the formula. Okay, so we call two-step problems. Okay, we call two-step problems. So that means, okay, so you draw, it says the height, let's draw the height, right? Height is h, that is h, right? So you don't know the height, but you can find it based on the what, that's my hint, right? So the area of the triangle BCD is gonna be half of the 7 times h. So what is h? Right, what is h? So h is a height. But can you get the height based on given information? What we're given? We're given the area of the triangle ABC. So the area of the triangle ABC still has the same height, okay? So 3 is the base times height is h, and divided by 2, and that is given, which is 7. Okay, we are given. So that h is going to be 14 over 3 because 2 times 4 is 4. 2 times 7 is 14. 14 divided by 3 is okay. So the area of the triangle BCD is half of 7 times h. Already know this. Okay, so it's going to be 2 times 3 is 6. Okay, and 7 times 14. And I think I can just simplify 7. It's a 7. So 49 over 3. Yeah, 49 over 3. 7 times 7 is 49. 49 over 3. So that is the area. Okay, we call it two-step problem. You're not going to give the height directly, but you have to find it. You have to find it. Okay, you have to find out. Okay, another one. Have a triangle, right? So this is A, B, C, D. And BD is going to be 2. DC equals 5. Okay, so 5 and 2. So if the area of the triangle ABD is going to be 5, right? So what is the area of the triangle on the right hand side? Can you get it? Anyone can figure it out? It's triangle, and the one's on left, the other one's on right. You know the base. One is 2, the other one is 5. You know the area of the triangle on the left. So it's if this is a centimeters, 5 cm, this will be 5 square centimeters. My question is, what is the area of the other side? As a triangle. Anyone has answer? Colin, Liu, do you have answers? I'll call your name. No, the answer is very simple. No. Okay, Eric. Eric, usually you have answers, right? Eric, geometry is hard, right? Eric.
It doesn't let me chat.
Right, the hint is to find the height. There's these 2 triangles that share the same height. Okay, so this is the height h. H is the height of both triangles. Okay, so on the left-hand side, so the area of the triangle ABD is going to be 2 times height, right? So that is the area of the triangle ABD, okay, which is 5. So from here you get a height. The height is 5 centimeters long. All right, then you use the same height, you can find the area on the right-hand side, ADC, okay, which is the base is 5. The height is 5, so it's 25 over 2. Done. Now there is an important formula by Heron. Okay, Heron's formula says that if you know the three sides, okay, A, B, C, okay, then area is going to be, area of this triangle is going to be a square root of S, S minus A, S minus B, S minus C, which S is half of the pyramid. Okay, so this is a very interesting formula because the triangle is uniquely determined by the three sides. So the area should be also determined, right? And this is a formula. It's very useful. Wow, if I know this formula, I can do all the problems, right? So let's take a look at the triangle here, right? And even you have a, you know, this is a, yeah, an arbitrary triangle. Okay. Arbitrary triangle, we got 3, we get 5, we get 8. And I think this is a triangle, okay? 5 plus 8 greater than 3. 5 plus, no, that's not. It's wrong, okay? So I have to shorten this. Okay, this is does not satisfy the right triangle. So what I'm going to do is I have to put a 7 here, or 6. Let's just do a 6, okay? This is the right triangle because 3 plus 5 greater than 6, 5 plus 6 greater than 3, 3 plus 6 is greater than 5. All right. The half of the pyramid is going to be 3 plus 5 plus 6, which is going to be 8. 8 plus 6, 14. 14 divided by 2 is 7. Okay, so the area is going to be 7. 7 minus 3, 7 minus 5, 7 minus 6. Okay, so I get 7, 4, 3, 1. No, 2. Yeah, 2. Okay, 7 minus 3 is 4. 7 minus 5 is 2. 7 minus 6 is 1. So now you get this, okay? And square root of 4 is 2. 7 times 2 is 14. So this is the answer. It's an irrational number, okay? So if you are given the triangle, okay, and this side is 6, this side is 6, the other side is 4, right? How do you find the area? Oh, I can even put, yeah, let me put a 7 here, 7, make it different. Okay. Okay. So there are a couple ways to find the area. Couple ways to find the area. One way is to find the height. Okay, find the height, right? So the height is a triangle 7H2. Okay. All right, so the right triangle is h squared plus 2 squared equals 7 squared. So h squared equals 749 minus 4 is 45. Okay, so h is going to be square 45. So once you know the height, and you can find the area. The area is going to be half of the base times the height. So it's 2 times square 45. Okay, that's there. Now, you can use a Heron's formula to get the same answer. It's kind of surprised. Okay, so let's do this problem again. I have a 7, 7, 4. Okay, half of the pyramid is going to be 7 plus 7 plus 4. 18. 18 divided by 2 is 9. All right, so the area is going to be 9. 9 minus 7. 9 minus 7. 9 minus 4. Okay, you know, S minus A, S minus B, S minus C, right? So you get 9, 2 times 2 times 5. So what you get here is 9 is 3 squared. So 3 squared and 2 squared and 5. So it's going to be 6 square 5. Now, what's the difference between this problem and answers above? I think we forgot to take simplifying square 45. Square 45 is going to be 5 times 9. So square of 9 is going to be 3. So that's why I got 6 square 5. Okay, it's the same answer essentially. So as long as you're given 3 sides, you can uniquely determine the area. Okay. So you're wondering why, how, you know, why is Heron's formula is true, right? You can maybe find the proof by yourself. But suppose if it was you, are you able, you know, a couple hundred years ago, were you able to discover this formula? Right? You know the triangles are uniquely determined by the 3 sides. So the area is also. So area depends on 3 sides. But can you figure out the dependency? Right? And the Heron find it. Right? So now I'm going to take a look at the rectangle. This is a rectangle. Okay, and here's a middle point. So rectangle is it's a 4 by 2 rectangle. Okay, 4 by 2. So consider 2 squares. Okay. So what I'm going to do is this is the middle point. That's wrong. Okay, I'm going to do the following. Okay, so I choose a middle point here and the middle point here. This is the middle point. So 1, 1, 2, and 2. I connect them. So I get A, B, C. Okay. Find AB, AC, BC, and the area of the triangle ABC. Okay. So you can use this as A, that's a B, that's a C. Okay. Let's find out. How do you find A and B, C? I give you 1 minute to think about. Okay. How do you find? Can you find A and B and C? All right. Anyone have ideas how to get A, B, how to find the letter A, right? AB is a C, right? So AC is B, BC is A. So let's find out ABC. you have to apply the Pythagorean theory. Okay, let's redraw the picture again. Okay, so I forgot here's A, B, C. Okay, so this is a 1, that's 2, right? Here's a 4, here's a 1, right? That's 2 and the 2. Right, but this is the rectangle, so those are all the right triangle. Okay, so A is going to be square root of 4 squared plus 1 squared by Pythagorean theory, right? So that's going to be 16 plus 1 square of 17. It's a very bad number. B is a square root of 2 squared plus 1 squared. So 4 plus 1, it's a square of 5. It's also an irrational number. C, and that is going to be 2 squared plus 2 squared equals square of 8. Right? It's 2 times 2 squared, so it's going to be 2 square root of 2. Anyway, so those are the numbers, pretty bad numbers. Okay, so the question is, how do you find the area? How do we find the area? Now, you can use a formula to find the area, but it's very complicated. We can use Heron's formula to find the areas because you already have the 3 sides given, right? But it will be very complicated. First of all, how do you find the pyramid, right? Half of the pyramid. Okay, that involves radicals. So I'm not going to do this this way. I'm trying to find the area in a different way. Can you figure out how to do that? Okay. Here's 1, 2, 2, 2, 4, and 1. Can you find the area of this triangle? Okay. Yeah, can you find the areas? This is a square root of 5, square root of 17, and 2 square root of 2. Can you find the area of this triangle? Think about it. Wow, somebody got it. Good job. Use a subtraction. Okay, you cannot use the 3 sides. Easily find, I'm saying you can, but you cannot use the 3 sides of the triangle, find the area, but you have to use a subtraction. Subtraction method. So area of the triangle is going to be area of the rectangle, 4 times 4, minus area of the 3 triangle around that, right? So, but 3 triangle around that is all the right triangles. So half of the 4 times 1, half of 2 times 1, half of 2 times 2. Okay, so that's why it calls 8, 2, 1, minus 2. So 8 minus 5 is going to be 3. Okay, that is correct way to do it. Okay, now if you use Heron's formula, and it's a radical inside the radical, so it's very complicated. But of course, after you simplify, it has become a simple formula. Okay, otherwise, it's indeed a very complicated. Okay. Okay, so here's another one. Here's 5, 7, and 10. Okay. I want to draw the height h. Can we find the h? Well, if you find the area of the triangle, okay, the area of the triangle is half of 10 times h is 5h. So if you know the area, you get h, right? But how do you find the area? But you are given 3 sides. So if you know the 3 sides, you should be able to get the area by the Pythagorean and by Heron's formula. Okay, I did not prove the Heron's formula here. But if you can search on the internet, maybe you find a simple proof. We will prove that in the next class called Advanced Mathematics. Okay. So let's calculate the area in different ways. So you are given 3 sides already. The half of the parameter is going to be, okay, this is going to be 5 plus 7, 12, 12 plus 10, 22, 22 divided by 2 is 11, okay? So the area is going to be square root of 11, 11 minus the first side, 11 minus second side, 11 minus the third side, okay? So I get 11, 6, 4, and 1, okay? So, so square root of 4 is giving me 2. 11, 6, all right, times 6 is 66. So that is the radical number. Okay, you cannot simplify. So now we have the 2 identity because those 2 are equal, right? So 5h equals 2 times square root of 66. So h is given 2 over 5 square root of 66. Done. Right. So given the area, and then if you know the area, you can figure out the height. Actually, all the height you can figure out. Like, okay, here's a 5, here's a 7, here's a 10. The height to the other side will be like this, right? So this is also the, let's call the another height, right? Let's call the, let's use a different letter, x, okay? Then I can find out the x also, because the area of the triangle is going to be, the area is going to be 2 times square root of 6, okay? 2 times square root of 6. But this is going to be half of the base times the height, right? So therefore, x is going to be 4 square root of 66 divided by 5. Yeah, that's pretty strange number, but you can get all the 3 sides. Okay, you can get this. Okay, so this is about triangle. Okay, and we know we can figure out the area using subtraction, right, method. If this is a triangle is inside a rectangle, we can use a Heron's formula to find the area if you know the 3 sides. And if you have a right triangle, you can apply the Pythagorean theory. Okay. Yeah. Okay. I have to stop here. Then this is about geometry and rectangles and triangles. Okay. And it seems to me you have some troubles. Not everybody can quickly do this type of problems. So pay more attention to the exercise and make sure you're able to finish that before the next class. And we have probably have one more class on the circles. Okay. Yeah, let's stop here.